Hey there, everyone! Welcome back to our channel. If you're new here, I'm your name, and today we're diving into a really fascinating topic that's crucial in the world of data science and machine learning, the ROC curve and AUC score. Whether you're a seasoned data analyst or just starting your journey into data science, understanding these concepts will help you assess the performance of your classification models. So, let's get started. But first, let me ask you a question. Have you ever wondered how we can visualize how well our model is doing when it comes to distinguishing between different classes? That's where the ROC curve comes in. So, what exactly is a ROC curve? ROC stands for Receiver Operating Characteristic. It's a graphical representation that helps us evaluate a binary classification model's performance at various threshold settings. Now, you might be asking, what's a binary classification model? Good question. A binary classification model is one that predicts one of two possible outcomes, like whether an email is spam or not, or if a tumor is malignant or benign. The ROC curve plots two vital metrics, the true positive rate and the false positive rate. The true positive rate, also known as sensitivity or recall, measures how many actual positives were correctly identified by the model. In simple terms, it's the ratio of correctly predicted positive observations to all actual positives. On the other hand, the false positive rate measures how many actual negatives were incorrectly classified as positives. It's the ratio of incorrectly predicted positive observations to all actual negatives. Let's break this down with an example. Imagine you have a model that predicts whether a patient has a certain disease. Out of 100 patients, 30 actually have the disease, and your model correctly identifies 25 of them. This means your true positive rate is 25/30ths, or about 83.3%. If your model mistakenly predicts that 10 healthy patients have the disease, your false positive rate would be 10/70ths, or roughly 14.3%. When we plot these values on a graph, we get the ROC curve. The TPR is on the y-axis and the FPR is on the x-axis. The curve starts at the point and ends at. The ideal model will hug the top left corner of the graph, indicating a high true positive rate and a low false positive rate. Now, you might be wondering, how do we interpret the area under the ROC curve, known as the AUC score? AUC stands for area under the curve, and it provides a single scalar value that summarizes the performance of the model across all thresholds. The AUC score ranges from 0 to 1. A score of 0.5 indicates that the model has no discrimination ability, meaning it performs no better than random chance. A score of 1.0 signifies perfect classification. The model perfectly distinguishes between the positive and negative classes. Generally, an AUC score above 0.7 is considered acceptable, above 0.8 is good, and above 0.9 is excellent. Let's look at another example. If you have two models, Model A with an AUC score of 0.85 and Model B with an AUC score of 0.65, you can confidently say that Model A is better at distinguishing between the two classes. Now, you might be thinking, this all sounds great, but how do I actually compute the ROC curve and AUC score? It's easier than you might think. Most programming languages and libraries used for data analysis have built-in functions for this. For instance, if you're using Python, you can use libraries like scikit-learn, which provides functions to compute the ROC curve and the AUC score with just a few lines of code. Here's a quick snippet to illustrate this. This code computes the ROC curve and plots it, giving you visual insight into your model's performance. So, to wrap things up, the ROC curve and AUC score are powerful tools for evaluating the performance of classification models. The ROC curve helps visualize the trade-offs between true positive and false positive rates, while the AUC score provides a quantifiable measure of performance. Remember, a higher AUC score indicates a better model, so it's something you'll want to keep an eye on during your model evaluation process. If you found this video helpful, please give it a thumbs up and subscribe for more educational content on data science and machine learning. And if you have any questions or topics you'd like us to cover next, drop them in the comments below. Thanks for watching, and until next time, happy analyzing!